Welcome and thank you for joining our webinar today, Preventing Baseline Drift and Pirated Software from Being Installed, featuring guest speaker, IT and security expert, Russell Smith. You're also joined by BeyondTrust CTO, Maury Haber, who will cover a few points about BeyondTrust PowerBroker for Windows solution after Russell's portion, so please stick around for that. My name is Sarah, your webinar host today. A kind reminder to please submit your questions via the GoToMeeting console anytime throughout the webinar, and we'll cover your questions at the end during our Q&A time. Also, today's session is being recorded. You'll receive a follow-up email containing links to the recording and the slides shown here today within 1 to 2 business days from now. The slides can also be immediately downloaded via the handout section in the GoToWebinar console. Additionally, if you are attending for CPE credits with ISACA, you can locate and download the attendance verification document from the handout section. So at this point, let's hand it on over to Russell, who's going to jump right in. Hey, Russell. Hi, how are you? And
hi, good. Thanks, Sarah, for the introduction, and welcome everybody to today's webinar. So a little bit about me before we get started. So I'm an independent IT consultant and I specialize in Windows Server management and security. I'm a regular blogger over at the Petri IT knowledge base, and also, of course, here for BeyondTrust webinars, and I have a couple of courses over at Pluralsight, focusing on Microsoft Azure. And if you're specifically interested in least privilege security, I have a book out at the moment that's dedicated to that subject. So you'll find lots of useful information there, not just about the technical problems that you might face, but also about the political challenges. So if you want to find out more, do head over to the publisher's website. So before I get to the main part of today's webinar, I'd just like to ask you all of a question. So if you see the little hands up icon on the GoToMeeting panel, you can just put your hand up if this is true for your organization. So I would like to know, has your organization implemented any form of application control? So it doesn't matter whether it's a technology built into Windows, like AppLocker, for instance, or whether it's a third-party product. So I'll just give you a couple of seconds just to raise your virtual hands if that's the case for you. Okay. Okay, so I can see that some people do have application control already going on. Okay, that's great. So, preventing baseline drift. And how do we actually go about doing that? But what is baseline drift? Let's just make sure that we're all on the same page to start with. So it's very common and has been very common in the past that organizations create a gold baseline image for their Windows client installations. And in that image, they include all of the applications, the drivers, maybe policies and settings that they want to roll out to their PCs. And this is what we call a baseline image. Now that's all very well and good, so you spend all of your time configuring that image, but once that image goes out and gets deployed to your users, if it's not managed in any way, we get a deviation from what you configured. So as time goes on, users, maybe they change some settings in the control panel, maybe they remove some apps or they install some unwanted apps, maybe some malware gets onto the device, maybe they update drivers and get some problems with that. Of course, can really be a problem, especially display drivers and all that kind of thing in Windows. And maybe they find even a way to bypass some of the policies that you have set. So as time goes on, we get a deviation from that baseline image that you put so much effort into creating, and users have created their own colorful version of Windows that's running on their devices. And I've tried to represent that in the slide you can see on the screen. And if you ever go and look at a computer that is unmanaged, that's been running even just for several months after it's been deployed, it can be a real mess. But what is the problem? What is the problem with baseline drift? The problem is, of course, it becomes very hard to support these computers, and they can even be a risk, especially if we're talking about a machine that gets infected with malware. But how do we go avoiding this problem of drift in our images? Well, there are several different ways and technologies that we could use to prevent this. Now, Microsoft are currently pushing modern deployment technologies with Windows 10, and I'll talk a little bit about that in a second. But the basic idea is you can avoid baseline drift if you don't have a baseline. And I'll explain exactly what I mean by that and how that works in a minute. Once you've deployed your computers, whether they've had a baseline or not, it doesn't really matter. You should use configuration management to make sure that all of your settings stay in place. And of course, you can choose Active Directory Group Policy to manage your computers, or maybe something like Microsoft Intune, which deploys mobile device management. If you do decide to use that legacy system of creating a gold standard image, try and make them as sparse as you possibly can, and then manage the image once it gets deployed. Maybe using, again, it could be group policy, it could be System Center Configuration Manager, but try and make that image as sparse as you possibly can. Of course, security has a big role to play in this as well. So we do recommend, of course, and Microsoft recommends very strongly that everybody should be a standard user. So nobody should have local administrative rights on their device. Okay, so of course you want to take away those rights to make sure users can't modify system-wide settings in Windows. And finally, even if you do take away administrative rights, that's not necessarily enough by itself to stop baseline drift and to stop malware and unwanted software getting installed on your end devices. So you also need to implement some kind of application control. Again, whether it's the built-in technology to Windows or a third-party product, you need to control what users are able to install into their user profile. Okay. So let's start with modern deployment technologies. So I mentioned a little bit about not using or not having a baseline. So what do I mean by that exactly? So let's look at Microsoft's modern technology approach and how that compares with the legacy options that we have. So here on the screen, we can see the legacy Windows deployment method that many organizations are still using with Windows 7, or even if they decide to deploy Windows 10. So we create that baseline image, and then we use a management technology like System Center Configuration Manager to push that image out to our Windows 10 clients. And that takes a lot of time to configure those images and make sure they work with our hardware. We have to find all the drivers, install all the software, and make sure all of the settings are in place. But in a modern deployment scenario, you've got a couple of different options. The preferred option is the cloud-driven option. Now, the idea here is that a user gets a new machine and that the IT department, by and large, shouldn't have to touch the hardware. Now, I'm not going to explain all of the details of exactly how this works, but it uses several different technologies, including mobile device management, MDM, Office 365 if you want to deploy an Office application suite onto your end devices, Azure Active Directory, and a new feature in Windows 10 called Windows Autopilot. And this allows a user basically to connect the device right out of the box, connect it to the internet, put in their corporate username and password, and then that device authenticates the user using Azure Active Directory, and the hardware ID for the device is sent to Windows Autopilot. We check, is that one of our devices? and that device is then configured for the user, and all the software, all the settings come from the cloud. We didn't have to configure any baseline image at all. This is all done using cloud technologies. You can also, of course, mix these two different ways of deploying Windows 10. So while Microsoft is encouraging people to use the modern deployment approach, so getting rid of a baseline image and managing your computers using the different technologies we've already discussed, you can, okay, well, we can't do everything in the cloud, so we'll do part of it using our gold standard image, and maybe we'll deploy Office using Office 365 and Microsoft Intune, for instance, which is Microsoft's MDM solution. So you can mix and match if you're not ready to make a complete move to a cloud-driven deployment scenario right now. In terms of Windows Autopilot, the cloud-driven scenario is designed for a user basically to take their new notebook straight out of the box and type in a username and password, everything gets deployed. But there's also another method that's, well, we don't want to do it like that. We want to set up the devices ourselves, the IT department, and you can also do that without the cloud or with the cloud. If you do it without the cloud, you use Windows Configuration Designer instead of MDM, for instance, and essentially that allows you to get the device into a state where it's configured just enough to connect to whatever your management technology is. So it might be, for instance, Intune, or it might be System Center Configuration Manager, and you can do that as an IT department, and it's a slightly different scenario, but you can also do this, and it's also without having to spend time configuring that baseline image. So what are you saying? What are you thinking? Okay, so, well, okay, that all sounds well and good, and that's fine if I've got a new device and it's going to come with Windows 10, that's fine. Okay, I can possibly consider using this cloud-driven deployment method and not bother going through the process of actually creating a baseline image to make sure that my computer is properly managed right from the outset. But if you're upgrading, of course, old hardware from Windows 7 to Windows 10, it's also worth thinking that, well, you should think about doing an in-place upgrade instead of doing a completely clean install. Now, a lot of organizations don't really think about this, but it's worth considering, because when you make that in-place upgrade, you actually get a clean install of Windows 10. And all of the applications, data and settings and drivers, whatever's required, are actually migrated across to Windows 10. And if everything goes wrong, it just rolls back and you carry on with Windows 7, no problem. Now, there are a couple of different caveats to this, but the main one is that you need to be upgrading 64-bit to 64-bit. So if you're running Windows 7 32-bit and you want to upgrade to Windows 10, going to be a problem, okay? But if you're already on Windows 7 64-bit, it's well worth looking at an in-place upgrade as a way of migrating to Windows 10, assuming that your Windows 7 images are already in good order and you haven't had a lot of baseline drift there, of course. So you need to have really good image there in place and make sure that everything is working properly. So once you've decided on a deployment method, and hopefully you'll go with the modern deployment method, which is without a baseline, if you like. But whichever way you decide, you need to think about configuration management to make sure that image stays the way that you configured it, that users are not installing unwanted software, that they're not accidentally getting viruses or malware onto their machine. And of course, there are different ways that you can do that, but the two ways that really you're going to look at are either Active Directory group policy or mobile device management. So mobile device management, probably you're aware, is something that is now built into Windows 10, so you don't need to install an agent on the device like you needed to do with Windows 7. For instance, you would need to install the Intune agent on Windows 7 to manage it. No more of that in Windows 10. You can manage it using either Microsoft's Intune solution or a third-party product. That agent is built in. So, what about mobile devices? Because a lot of devices now, they don't, of course, sit in the office. They're all over the place. Some of them may never even come physically into your office. And the great thing about NDM is, of course, that it reaches beyond your corporate intranet, because you have that connection out to the internet. It's all cloud driven. Whereas if you manage your devices with a group policy, you need to make sure your devices, when they're out of the office, have some way to connect in order to get group policy updates. And of course, MDM can be used to manage lots of different devices, not just Windows devices. And of course, you can also use it to manage applications as well, not just the operating system. If you have a more traditional setup, for instance, you have a fleet of PCs that never leave the office, or you need very granular control of Windows, then group policy might be a better option. Of course, it requires Active Directory. Of course, some businesses now don't always have Active Directory on site, so they might not be able to use group policy. And there is a lot of support for existing and mainly legacy third-party applications. So there's group policy support for Office, of course, but also things like Adobe Acrobat Reader and Google Chrome and all of these things. They all have group policy support. So these are the two technologies. Of course, MDM is the modern one that Microsoft would like you to go with, but both of them at the end of the day can be used to make sure that your computers stay configured as you would like them to be configured. So, what can we do in more detail with these two technologies? So we can manage software settings, and we can also deploy software, whether that is from the Windows Store for Business or whether it's a legacy Win32 app. We can, of course, configure system settings in Windows and make sure that our systems are secure. So we can configure and deploy Windows security templates to our systems and make sure that Windows Update is pulling updates from the right place. So it might be Windows Update for Business, or you might have a local Windows Server Update Services device that you want to use. We can use group policy preferences, of course, to customize our user environments. So we might want to install printers or configure network drives for our users. We can also, using both of these technologies, by the way, not just group policy, we can manage App Locker, which is the built-in application control technology in Windows 7, and we can also manage Windows Defender Application Control, which is a new technology, application whitelisting technology that's built into Windows 10. So with these two configuration management technologies, we can update and change the settings at any time and make sure that our baseline, if we're using a baseline, stays in place. Even if we're not using a baseline, we can still make sure that our devices are configured exactly as we would like them to be. So I mentioned that security also plays an important part in all of this. And of course, this also goes and connects back a little bit into configuration management, because in order to make sure that the configuration isn't modified without our knowledge, we need to secure the device to make sure that users can't make whatever changes they would like. And of course, the key to doing that is to use a standard user account. But there can be some disadvantages to standard user accounts. So of course, we get a lot of convenience with the local admin account. The user can do whatever they want, but it can also cause a lot of problems. So of course, baseline drift is one problem, that they can change anything that they like and even potentially override any policies that you've put in place. If there's a security issue with the machine, we could also be talking about potential data loss on that device. Of course, we're all aware about threats like ransomware and all this kind of thing that's been in the headlines over the last couple of years. And for many organizations, they simply need, of course, to make sure users are not running with admin rights for regulatory reasons. And of course, that also applies to many organizations. The problem with standard user accounts can be that not all legacy apps want to play nice with a standard user account. That is becoming rarer and rarer, but of course, businesses, they still have legacy applications that they need to keep working. Some Windows features that a user might need to access might not be available as a standard user. You can't rely on your users anymore to update or patch applications. That's something you will have to automate as an IT department. Okay. Probably not too much of a problem in general, but can be an issue if a user wants to add a piece of hardware but the driver isn't signed, or the driver isn't built into Windows or available for Windows updates. Again, a problem becoming rarer and rarer, but could be an issue. And the final thing, possibly very significant, is that it can be harder to support users that don't have administrative privileges. Because if you need to change something that requires administrative rights, how are you going to give them those privileges? This is also something that you need to think about. There are some technologies, of course, that help you to overcome those problems. Now, I've mentioned user account control here. It's really a consumer technology. It's not really designed to help businesses as such, but it's just worth mentioning that there is a lot of work done with the user account control, and it kind of incorporates several different technologies. Actually, it's an umbrella term. So, for instance, user account control, when it's switched on, and it should be switched on, will help legacy applications that don't like standard user accounts to run, because user account control contains a technology called file and registry virtualization. So that was all part of user account control. You've also got the application compatibility toolkit for those difficult applications that don't like standard user accounts. And you can use that, it's a free download from Microsoft. You can use that to apply application compatibility shims to your devices. And basically what those shims do is they trick the application into thinking that it has more rights than it actually has. And then, of course, there are third-party privilege management solutions, which make the whole thing a lot easier, okay? Because Microsoft tools, while they work, they don't necessarily scale. They can be difficult to implement, and it's not the easiest thing to work with in the world if you've ever tried to use any of them. So I also mentioned that taking away administrative privileges isn't enough by itself, that we need to protect the user space, what the user can run. What I mean by that, for instance, is portable applications. Some malware, of course. Malware writers, they understand that users don't always have administrative rights, and their malware might quite happily install without administrative rights. Google Chrome, for instance, can be downloaded as an application that installs in the user's profile. You don't need administrative rights to install that application, and that, of course, applies to lots of applications now. So, what about the built-in technologies into Windows? So I mentioned App Locker, and this came along in Windows 7. It was a kind of an evolution of software restriction policies that we had back in Windows XP. So what does this allow you to do? It allows you to create a whitelist of applications, and only these applications will run on your devices. Okay, and it doesn't apply just to applications, it also applies to scripts and packaged store applications. And of course, you can use this to make sure that users are not running software that you haven't sanctioned on your network. Windows App Locker can also automatically create a whitelist by scanning a reference machine. So you don't necessarily need to go through and manually find every piece of software that you're running and add it to a list. But in Windows 10, we have a new technology. Originally, Microsoft referred to it as Windows Device Guard. And everything got a little bit complicated, as everything usually does with Microsoft. Nobody really understood Device Guard and what they could and couldn't do with it. So Microsoft divided it into two technologies. The first of which is Windows Defender Application Control. Now, again, this is an application control technology. It's not really an evolution from AppLocker because it's based on a completely different system. But it does everything that AppLocker does and quite a lot more. So it works by configuring code integrity policies. And a difference with this and with AppLocker is that these policies are actually enforced by the Windows kernel. So it's designed to be a very robust system. And you can block unsigned apps, Microsoft installers, and any kind of code that might run on that system that you wouldn't want to run. And you can also even block things like browser plugins. So it can be quite granular in actually what it can be used to block. Windows Defender Exploit Guard is now a separate technology. And basically what this does is it uses hardware-based virtualization to protect the Windows Defender application control code integrity validation processes, if you like. So ultimately, what this tries to do is say, well, if the Windows kernel was exploited, hacked, if you like, we would still be able to run there's a validation code to check that users can't run software that they're not supposed to run, even if the kernel was exploited. Okay. Now, this does require that the hardware supports certain hardware-based virtualization technologies on the processor itself. But you don't have to turn on Exploit Guard in order to use application control. And this is what a lot of people didn't understand about it. You can use Windows Defender application control on its own. The Exploit Guard part of it is like a bonus. If you can enable it, it will make it even more robust. Okay, so bear with me. So I should probably say that Windows Defender application control is probably a little bit more complicated than AppLocker, it would be fair to say. It's very flexible, it's more robust, as I've said. There is no GUI, so everything is done using PowerShell, and it can be a little bit difficult to get your head around it. But basically, these two technologies together, application control and exploit guard, Microsoft still refers to them as device guard, which is a little bit confusing. Okay, so device guard, what does this mean? This is application control and exploit guard together. Okay, so you can see here on the slide that we have code integrity policies enforced by the kernel. How does this differ from AppLocker? You can protect not just user mode code, but also code that runs in the kernel itself, like kernel mode drivers. You can protect these code integrity policies from local administrators. So a local administrator can turn off AppLocker if they want to. But it's much harder if you digitally sign your code integrity policies. It's much harder for an administrator to turn those policies off because they would also need access to your corporate digital signing process. Okay, And as I mentioned, exploit guard provides an extra layer of protection to this entire mechanism should the Windows kernel become exploited. So these are the main differences from AppLocker. You can see that it's a much more robust technology. So how does it all work? Okay, so from start to finish, I'll try to just give you an overview of what you would actually need to do in order to turn on application control. So some of these things are optional. So I mentioned about digitally signing your code integrity policies. You don't have to do that, okay? But you can. It's an optional step. So the way that it works is that you use PowerShell to scan a reference computer. So a little bit like the way that you would scan a computer using AppLocker, you can scan a computer, a reference computer. Let's look at this device and let's see what we've got installed there. We want to let everything there run in our policy. You then enable that policy in audit mode, okay? And once that has been running maybe for a couple of weeks on your computers, you have a look to see what's been logged in the event log, and you can run the PowerShell commandlet again and create a second policy, including all the applications that have been blocked, but you would actually like them to run in your policy. And then you merge those two policies together using that information, and you deploy the final policy to your computers. Again, first in audit mode. Once you're sure that no applications that should be running are being blocked, you can then enable it. If you want, it's perfectly optional. You don't have to do it. You can also configure exploit guard to protect that process even further. So that's the basic idea. I haven't mentioned the point in the middle there about creating a catalog file for unsigned apps. It's not strictly necessary to do this. You can actually include unsigned apps in your code integrity policy without doing this step. Okay, so I'm just not going to talk about that for the moment because it makes everything a little bit more complicated. But you might want to create a catalog file on a server. Okay, so here's some PowerShell, so don't be scared, okay? If you're not familiar with PowerShell, I'll just briefly describe what's going on here. So we've got our reference machine and we want to scan it to create an initial policy. What have we got on that device? So I've created a couple of variables there, a file path and two files, okay? So the actual policy itself, in its initial state, is an XML file. So you can generate it using these PowerShell commandlets, and once it's generated, you can edit it by hand if you want. So we use the new CI policy commandlet to actually scan the computer, okay, to run this initial scan. And there are lots of different file levels that we can set. So you see the level parameter there, and it's set to PCA certificates. So we want to make sure that we're using only signed applications, and we're going to scan this reference device, and we're going to have a look to see which certificates are required to make sure that those applications are allowed to run. And it makes a list of all those certificates, and basically that's what it does, okay? So we will allow all of those applications to run on the device. And that generates the XML file. And then we convert that XML file into a binary file. So you can see there device guard policy.bin, and that file we put into a group policy object. This can be done with MDM as well, but here I'm just showing you the group policy object setting. And we just make sure that file is available, that bin file is available in a place where it can be accessed. And we put it in there, and by default, the policy will be in audit mode. Okay, and we restart the computer, and application control will start logging any applications that are not allowed to run according to that policy. Once that's been running, we capture that information from the event log. Okay, so we want to know which applications have been blocked. We don't want them to be blocked. We want them to be included as well. Okay, and we do something similar. You can see a couple of variables there that I've created for the file path and the file name. And we just run the new CI policy command again, but here you can see with the audit parameter, and this time the file level is set to hash, because what you're going to get in the event log, what is not going to be allowed to run? Of course, it's going to be unsigned applications. So we need to use a file hash instead of a certificate to allow those applications to run. Okay, and then we, of course, we get a new file, this time device guard audit policy.xml. So we have those two policies that we just merge them together. Okay, so again, you can see here that I set out all of my file names, and my file path. So I've got the initial XML policy, the policy that we created from the event log audit, and I'm going to create a new XML, going to merge them together into merged policy XML, and then finally I will convert that merged policy XML into a bin file, which I can send to my group policy object. And that's all there is to it, really. Okay, so once you've got that final policy, you should run it again in audit mode, maybe for another couple of weeks, just to make sure that you didn't miss anything. But at some point, of course, you'll want to enforce it. So again, we come back to PowerShell, and if you remember, I said that policies by default are in audit mode. So we need to change that policy and make sure that we take away that audit mode option. So again, I've set a couple of variables there for my file path, my file names, and you can see two command lists there, set rule option. Now, Microsoft recommends this when you first enforce an application control policy. It adds two options to the boot menu, so that if, for whatever reason, the application control policy caused a problem that stopped the device from booting, an administrator can actually rescue that machine by going into the boot menu. You don't have to do that, but it's a recommendation. And finally, you'll see a third set rule option commandlet there. And you can see option free delete. Option free is the audit mode option. I want to remove that from my policy so that we actually enforce these rules. And again, once I've got that XML configured, I've removed that audit mode policy. I just convert it again into a bin file, put it back into my group policy object setting, and I need to reboot the computer to make sure that it takes effect. Okay, so there's quite a lot of information there. It might seem very complicated. It can be quite complicated. It's not the easiest thing to set up in the world, but it can be as simple or as complicated as you want it to be. What really makes this really flexible is the ability to merge policies. So you can create lots of different policies, you can merge them together, you can even have different file levels going on at the same time. So you can say that some things are authorized by a certificate, some things are applications or code is authorized to run by a file hash. If you've used AppLocker, you'll be familiar with those concepts. So do we want to make sure that the executable is signed by a particular publisher, or do we want to make sure that that file, before it's allowed to run, are we just going to use the file hash? If you use a file hash, of course, it becomes a problem when the application is updated, because the file hash will change. Okay, so you need to think very carefully about how you're going to deploy application control. But it is very flexible, more flexible than AppLocker for sure, and more robust. So do have a look at it. And it also works on Windows Server 2016. So you can use it to make sure that the software running on your servers is absolutely only what you have decided to run from your baseline image. Nothing else is allowed to run there, malware or what a rogue administrator installed or whatever else. Okay, so now I'm going to hand over to Maury, who's going to talk a little bit about Beyond Trust's product.
Thank you, Russell. It's an excellent presentation and understanding a lot of the problems that potentially face with baseline drift, illegitimate software, shadow IT, etc. My name is Maury Haber. I'm the Chief Technology Officer for Beyond Trust, and I'd like to introduce you to PowerBroker for Windows. This is an alternative to Device Guard, as Russell has presented today, to make it easier to do application control, least privilege, and a few other technologies built into the solution to solve those problems that we know still exist in Windows 10. Next slide, please. With these concepts in mind and the problems that Russell has indicated, we often know within our organization we have problems with too many people being administrators over the desktops. And that includes even help desk personnel that might have admin rights to fix a broken desktop. The whole point here is if we reduce privileges, remove them, make everyone a standard user, but allow applications and allow tasks to occur elevated, we can prevent breaches. We can certify easier for compliancy, whether that's PCI DSS or regional laws, that there is no admin access to a database, to an operating system, to fundamental applications. The whole point is to stop privileged abuse, to stop the baseline drift because someone doesn't have administrative rights to actually cause baseline drift. They can't change those settings in the control panel. They can't add software that they're not supposed to. But if the task does say, look, I have to change the system clock, which you still can't do when Windows 10 as a standard user, you can. And we find that to be quite frequently a requirement because we may have mobile workforces that are using their laptops worldwide. So how do you deal with removing admin rights but not obstruct productivity or overburden the help desk? You can easily go down the device guard route, learn PowerShell, manage those scripts, deploy them out, QA them, test them, or you could use a tool, a graphical tool, like PowerBroker for Windows from Beyond Trust to solve that goal. Next slide, please. With PowerBroker for Windows, we want to really solve that Windows management challenge and go beyond that. Not just the typical device guard concepts of app control, but also managing privileged activity to the file system, doing session recording, capturing the screen and keystrokes when privileges are granted even to a sensitive application, whether it's older or newer, and even monitoring the Windows event log for some type of unauthorized privilege change, like turning off a service or even installing a new service. Think of it from an attack chain perspective. Think of it as chess pieces, as illustrated on the left-hand side. Pawns are sacrificed in a game of chess, but your pawns are key. They will help you corner the king because the key to the kingdom is the king. It is where your sensitive data lies. It is where your critical applications are, and it is all about lateral movement. Lateral movement can only occur in two ways: vulnerability exploit combination or privileged escalation. If you eliminate privileged escalation up front, keep everybody as standard users, it's much harder to navigate through the enterprise from a threat actor's perspective to gain access to that data. And that's the point of application control. That's the point of why Microsoft is deploying these tools. But they can be difficult to use, and there are good alternatives. Next slide, please. So I'd like to bring into focus PowerBroker for Windows. It is specifically designed to handle those challenges and make it easier to administer with fine-grained privilege control, local session recording, file integrity monitoring, threat-based analytics, and even real-time vulnerability assessment to measure the risk of applications on an account-by-account basis to determine if they should be given privileges. Because what's the easiest way to hack a system? A vulnerable application running as an admin, right? It's one of the easiest. We don't patch our systems well. We already know that. But if you give it admin rights, it's even easier. Russell, in thinking about this for a second as an alternative or a commercial alternative to what Microsoft has said, what would you think is some of the best ways of removing admin rights or eliminating baseline drift with the removal of admin rights? What are some of the concepts that you generally tell people to look at?
Usually, starting off, of course, you need to do a lot of testing in terms of and making sure that software is going to carry on working. And as I mentioned, also being able to support those users, especially when we have companies with lots of workers in the field. It can be a real problem for support as well. So you really have to start looking at, from a very high level, about how that software is going to work, how it's going to be updated, and how you're going to support those people, and whether the tools that are available from Microsoft can really help you meet those goals. Of course, they might be able to, but if your environment is changing a lot, that also might be a problem. If you have a very simple environment where very little is changing, it might be that the Microsoft tools would be enough, for instance. But when you have an environment where maybe software is constantly changing or being updated or this kind of thing, or maybe you have a lot of field workers, then the likelihood is that those tools are not going to meet your needs. So you really need to evaluate what's out there and understand what your organization's situation is.
That's an interesting point. So if we were to consider that baseline, that gold image that you started with, that'd work great for like a call center or a sales team, right? Because they all should be using similar apps. And something like the Microsoft toolset would probably work pretty well. But from what you're implying, developers, environments that may do software testing, technology companies would generally have problems because of the flexibility need. Is that correct?
Yes, yes.
Okay. And that would imply that you need a better way in some ways. So this is one of the use cases that PowerBroker for Windows can fit is if your machines are all not standard, yeah, you may have started with a gold image, but the end result is not the same. Or if you're going from Windows 7 to Windows 10 and you still have admins out there and your goal is to remove all admin rights, but they still have a couple of those legacy applications, whether they're old terminal servers or even modern things like Tanium or QuickBooks that still need admin rights. There's got to be a better way to solve it. And that's one of the things what PowerBroker for Windows can do. Next slide, please. When we talk about the features of PowerBroker for Windows, we start talking about fine-grained granularity because the elevation of applications can be done by publisher, hash, path, even by if a vulnerability is present. It's capable of doing session recording. If an application is launched, it's being monitored. It will do screen capturing, even with GDPR compliance of letting the end user know that their screen is being recorded and obfuscating the data, including the username, in a central location so it can't be tracked back to the individual user. There are ways of doing, remote host execution where you have contractors, support teams, or anybody else coming into the system that needs admin rights, but the standard user doesn't, so that they can help, they can teach, they can make changes. And all the way down the list from monitoring child processes, one of the easiest things to do is go into Word and do a file open and double click on an executable and let it launch. Making sure that things like that don't happen through file integrity monitoring as well. So while Device Guard and App Locker can do quite a bit, you have to be able to say, look, I'm going to be doing application control, and I am going to grant admin rights or grant applications the ability to run. What do those applications and users do when they're granted permission to run or run as an admin? Can they touch the registry? Are they putting sensitive files in sensitive locations? Is the person doing something potentially malicious? And those are all features of PowerBroker for Windows that Microsoft doesn't have natively to give you the value add outside of not learning necessarily all the cryptography of PowerShell to get there. Next slide, please. So how we all do of this is in the PowerBroker Privileged Access Management Platform. It's typically called Beyond Insight. Many organizations will start with typically password management, the simple check-in, check-out, and automatic rotation of passwords, whether they're used for account check-in, check-out, or even service accounts. The ability so passwords are never known. People never use the same password. They're always changing. They're highly complex, and in many cases, not humanly readable. In the middle, we're focusing on the endpoint, removing admin rights there. No one ever has admin rights. We take that best practice of standard user, deploy it everywhere, and only the applications themselves get elevated. And we don't do it from a Beyond Trust perspective using an impersonation account. There are is no account that the program runs as instead. This is actually patented technology where we swap the security token for the application, pop up with a justification that the end user has to type in if required, and then the app runs. So techniques, memory scraping techniques like pass the hash don't work because the token is only valid for the application, not the user, and it can't be scraped for lateral movement. And similar techniques actually apply on the server side, Unix, Linux, Windows as well. So even a help desk staff technician going into a server to cycle a service doesn't have admin rights. They only have access to the services that they're supposed to be able to cycle them. So removing admin rights can help you everywhere, not only on the desktop, but even on the server. Next slide, please. With that, I'd like to wrap it up, pass it back to Russell for some concluding comments, and then over to Sarah for a quick poll. Thank you.
Okay, thanks, Maury. And I think it's worth having a look at Beyond Trust products because even if the little bit of PowerShell that I showed you for Device Guard wasn't enough to scare you, it can get pretty complex. But it is interesting to have a look at what's built into the operating system, and I think that you'll probably then appreciate a third-party product even more after having looked and delved a little bit deeper into Device Guard. Okay, thanks everybody. So I'll hand back to Sarah.
Thanks, Russell. That's a perfect transition for our poll. You should see that now pop up on your screen, everybody. And if you would like to schedule a personalized one-on-one demo of any of our PAM products, or even just to have a conversation with a Beyond Trust security expert, please select yes. And then somebody will be in contact with you to schedule that out. If you say no, it's okay. It won't hurt my feelings. But we really want to help you in all of your PAM deployments. So please select yes, and let's get a conversation going. Okay, so now we've got some questions that came in. Again, audience, if you have any questions live for Russell, please submit them. I already received a couple, but if you have any more, well, we have him on the line. Please send them in right now. And Russell, first question for you. So what version of Azure AD is required for autopilot?
For autopilot, you need the premium version. So there is a basic free version. The premium version you do need to pay for, but you can also get it as part of the Enterprise Management Security Suite. So if you want to pay for Intune, for instance, and Azure AD, you can get that as a package. You don't necessarily have to buy those things individually.
Russell, where can I get the Windows Configuration Designer?
The Windows Configuration Designer comes as part of the Windows ADK, so it's the Assessment and Deployment Toolkit. And you can also download it as a standalone application from the Microsoft Store.
Russell, what version of Windows is required for Windows Defender application control?
You need Windows 10 Enterprise.
Okay, let's see. I don't know if this is for Maury or not. I want to know, can we control user access to view read-only information for other users, like their personal information, last password, set, et cetera, from the net user command line? Or is that maybe for Russell? I'm not sure. Can one of you guys jump? Do one of you guys understand that?
Not sure exactly what the question is getting at, what they want to know exactly.
Yeah, neither am I. However, you can control PowerShell commands and old school DOS commands through PowerBroker for Windows, depending on the privileges of the user to begin with. Yeah, I need more details on that question. So whoever asked that, please answer that poll yes, and we'll have an engineer happily answer that for you.
Okay, folks, it is time to wrap up. Be on the lookout for our post-webinar email containing links to the recording and the slides shown here today within about 2 business days from now. A big thanks to our experts, Russell Smith, Maury Haber. Thank you, gentlemen, very much for being here today. And to all who attended live, have a wonderful rest of your day. We will see you at our next webinar. Take care, everybody, and goodbye.
Thank you. Bye-bye.
Cheers.